let's talk about PCBs. It's simpler and easier, and eventually, in general, maybe to call it additive manufacturing of circuit boards. Probably, I will start by saying that the PCB that you see here is actually printed with copper ink. So, as a starting, so just few words about Copprint. We are fully focused on copper ink, making manufacturing with lower cost, more sustainable, and wherever you want it, either replacing silver inks that are more expensive or PCB etching that is polluting, hazardous, a lot of carbon footprint. Copprint is very well known for its clean tech impact, being part of the top 100 clean tech companies, private companies in the world. And last year receiving a very interesting honor from Logitech for our contribution to the PCB industry, and we will talk about it later on. So in general, we are all in the world of electronic, and in every electronic, we have a board or a conductive pattern. We usually call it a PCB. Just why do we call it a PCB? A PCB, as the acronym, is a printed circuit board. But the PCBs that are made today are not really printed. They are made using chemical etching. So why do they call them a PCB? So just about 100 years ago, the first PCB were patented and fabricated. They used conductive paste made out of silver and to print it on a board. You can see here actually the first patent on a heater made with silver paste on a substrate to make a coil. And then in World War II, people have used silver inks in order to print multi-layer PCB. On the right-hand side, this is the only image of this PCB that was a proximity fuse in a missile made by the US in World War II. And these were manufactured in quantity by printing. So in 1948, you could find a great book. There is a link here, or if people want to see it, it's really an amazing book to talk about new advances in printed circuit boards. So it's not new for today, it's new for 1948. And you can see here the explanation of how you make a board and how you print it actually with stencil. And you can see here the silver circuit wiring, blah, blah, blah. So this was until about 1948. And since the 1950s, people moved to do chemical etching, but they still keep the name of PCB. So how do we work today? There is one way still to print silver. People are using it mainly for photovoltaics and for consumer electronic, usually to make keyboards, membrane switches, and various sensors. So this is one option. It's a $5 billion market, by the way. And the more classic way to make PCBs is by chemical etching. You start with a copper sheet, put it on a substrate, put it in this toxic chemical that cut the copper and are toxic. If they can cut copper, they can cut other things. It's very hazardous. Actually, only recently we made an interesting study of what is the CO2 emission of the PCB industry, just to make the boards, not the electronic component, just to make the board. And actually about 0.5% of the total world CO2 emission is made just when you make the PCB, and about 50% of this is just the chemical etching process that we are going to eliminate in an additive process. So with copper inks, you can simply print using screen printing and using other printing technology I will review later in order to make conductive patterns. If you are shifting from etching to printing, it makes a lot of sense from a process which has a lot of steps and a lot of ways to a simple printing of copper ink, and you are cutting about 50% of the CO2 that is made with the PCB. And this is really a huge amount. If you will transform all the PCBs in the world to our methodology of additive manufacturing, you will save about the same amount of CO2 that a small country is actually making. When you're moving from silver inks to copper, again, a major CO2 reduction of about 100x and much lower